Let's talk about the squeeze theorem. So on the screen, you can see the squeeze theorem written out. It says if g of x is less than or equal to f of x is less than or equal to h of x for all x that are near a, not necessarily at a, and the limit of g of x and h of x as x approaches a, they both have limit L, then the limit of f of x as x approaches a is also L. This theorem always looks worse than it is when we're seeing it like this. So I've highlighted in red here f of x at the top of the theorem to emphasize that the limit of f of x is the one that you're concerned with computing in a problem where you're using the squeeze theorem. So you have your function and it's sandwiched between two other functions, at least for like the neighborhood around where the limit is happening. Very often it happens for all x's, but it's at least x's that are near your number. So if your function is trapped between these two functions, and both of those functions have the same limit at a, then that means they're kind of squishing your function to the same limit as well. So if both of those guys have that same limit, then that number is your answer. All right, so let's see this in action. I have two examples that we'll talk about here. So the first one says, if f of x essentially is a mystery function, we're never going to see its formula, but it's between 0 and x squared for all x. What is the limit of this function as x approaches 0? And I have kind of a rough sketch visual of what's happening here. So 0, y equals 0 is the x-axis, and then y equals x squared is this parabola. And our function f of x could be doing anything that's trapped between those two graphs, right? So 0 on the bottom, x squared on the top. Our function could be really, really wacky, but we can still compute this limit using the squeeze because we have it kind of sandwiched between. Okay, so we know that 0 is less than or equal to f of x, less than or equal to x squared. So for this function and this function, the far left and far right ones, I want to compute the limit as x approaches 0 because that's the limit I'm being asked for in the problem. So I need to compute x approaching 0 of the 0 function, which of course is just 0. And then also the limit as x approaches 0 of x squared, which we can just plug in 0 and we also get 0. Okay, so we do need something specific to happen in this step. We need not just to compute these limits, but they have to come out to the same number for us to keep using the squeeze theorem, right? So fortunately for us, they both came out to 0. So my answer is that this limit is also 0. If these had come out to different numbers, then the squeeze theorem doesn't apply and we're just stuck and we can't use it in this case. Let's see the second example. It's going to go similarly, and then I have two limits that we can discuss. So again, we have a mystery function f of x, and we're being told that whatever it is, it's trapped between 4x minus 5 and x squared minus 1 for all x. Okay, so the first limit we're asked to compute is x approaching 2 of our function. So I'm going to take the limit of this function as x approaches 2 and this one. And as long as they come out to the same number, that will be my answer. Each of these is a continuous function where we can just plug in 2. The first one I get 8 minus 5 is 3. The second one I get 4 minus 1, also 3. And I say, oh, okay, so it's squished between these two functions. Both of these functions are going to 3. So mine is also going to 3. So that's my answer for the first part of the question. All right, the second part of the question is asking for the limit of the same function as x approaches 0. So we're going to attempt to use the squeeze theorem again. So I'm going to go back to these same two functions, but now I want to compute the limit as x approaches 0 of each of them. And again, I can just plug in 0 to each of them to compute this limit. I get -5 for the first one, -1 for the second. So because these didn't come out the same, the fact that my function is trapped between them means, I guess its limit is maybe somewhere between these two numbers, but the squeeze theorem does not apply here. So we'll say the squeeze theorem doesn't apply in this case. And we're actually going to stop there on this one because we just don't have enough information to answer the question because we don't know the formula for f of x here. So what this would mean, if you were in the real world and you desperately needed to compute the limit of this function at 0, you would either need to find different functions for this spot and this spot here that still make this true, but then have the same limit at this moment. So that's your answer. Or you would need to use something that isn't the squeeze theorem. So what we need is two functions on either side that squeeze the function, and then they have to have the same limit at that point for that to be your conclusion.